Good morning to everyone. EC 8791 Embedded and Real-Time Systems for the final year 7th semester Regulation 2017 for EC Department Unit 1 Introduction to Embedded System Design. So in this previous slide we have seen the various concepts of embedded system design and what are the various classifications of embedded system performance and what are the examples of embedded system. So we have seen in last class. So in this slide, we are going to see about what is meant by microprocessor and what are the design methodology for embedded system design. Okay. So why we go for this microprocessor for an embedded system design? There are two reasons for microprocessor which we have implemented in a very efficient way. The second one is the upgradability. So various features at different price points and can be extended to provide new features to keep up with the rapidly changing market. Okay, so for these two reasons, we are going for the microprocessors. The second one is what are the challenges in embedded computing system design. So challenges means how much hardware we do need and what are the need deadlines and the power consumptions, upgradability, reality it's working, complex testing, observability and controllability, restricted development environment. Okay, so for these reasons, the challenges are optimized in the embedded computing for complex systems, complex system designs, and we have to check the functionality, hardware, power consumptions, and the deadlines. Okay. So the next one is performance in embedded computing. So the embedded system designers, in contrast, have very clear performance goal in mind. So the heart of the embedded system is a processor. So processor means how people dumping that particular program that will detect the behavior of that particular embedded system. Okay. So that deadlines that program also meets a deadline constraints of the particular program. Okay. So the CPU platform program task multiprocessor. Okay, the CPU clearly influences the behavior of the program, particularly when the CPU is pipelined processor with a cache. So the platform includes the bus and I/O devices. The platform components that surrounds CPU are responsible for feeding the CPU and can dramatically affect the performance. The program are very large and the CPU sees only if the small window of the program at a time. Okay, the task means a program simultaneously on a CPU, creating multitasking systems. Okay, so every embedded system is a multitasking environment. So for example, a mobile phone, a laptop, as a not laptop, a mobile phone, and what is meant by a washing machine. So all other systems are belongs to multitasking environment. So the multiprocessor means many embedded systems have more than one processor that may include multiple program CPU as well as accelerators. Okay, so these are all the constraints when we go for one multiprocessor, when we go for the performance of embedded systems. So what is meant by the design methodology? What is the embedded system design process? So we are going two reasons for the embedded system design process. The first one is embedded system design that will involve various steps. Second one is considered for the methodology. Okay, so for these reasons, we are going the embedded system design process. The first one is requirement, second one is analysis, third one is design, fourth one is implementation, the fifth one is testing, the sixth one is grading. Okay, so these are all the various design methodologies, design techniques when we go for this embedded system design process. Okay, so the design methodology is important for three reasons. The first one is we have to ensure the performance. Second one is we have to create it should create it won't be a daunting task when we go for this automatic. Then third one is we have to ensure that all the team members can easily understand the support what should to receive from the team members. Okay, so since embedded systems are designed by teams, coordination is perhaps the most important role of well-defined design methodology. Okay, so for these three reasons, we are going the design methodology for the embedded systems. So an embedded system design process, requirements, specifications, architectural, and the components and the system integration. For these five reasons, we are going this embedded system design process. There are two types of process. The first one is top-down design process. The second one is bottom-up design process. So the top-down design process will begin most abstract description of the system that will conclude concrete system with concrete details. The second one is bottom-up view in which we start the components to build a system. So we need a bottom-up design because we do not have a perfect insight into how later stages of the design process will turn. Okay, so these are at the bottom up and top down approach. So the major goals of the design, we should analyze step to determine how we can meet the specifications. The second one is refine the design to add details. The third one is ensure it still meet the system goals such as cost, speed, and so on. So every embedded system will have goals like the cost, speed, performances, and quality. So power consumptions, cost. So these are the major goals of the particular design. So what is mean by requirements? Okay, so the first phase of the embedded system design is called a requirement. Requirement will determine the capture of the basic functions of an embedded system. Okay, so the non-functional, there are two types of requirements. The first one is functional requirements. The second one is non-functional requirement. The performance means non-functional requirements are performance, cost, physical size, and weight and power consumption. So the performance means speed, usability, particular operations. Cost means components and assembly and the personal cost. Power, physical size and weight means designed to fit that particular size. It should be compactable. Power consumption means battery life. Okay, so these are the non-functional requirements. So in this requirement form, we can use the name of the particular product, the purpose of the entire product, inputs, functionality, output functionality, functions, performance, manufacturing cost, power, physical size, and weight. Okay, so these are the requirement form. Then we go for the requirement collection from the client to the industrial point of view. So that industrial team will gather all the record information to design that particular product from the client. Okay, so in this design example, we are going to see about the global positioning system for a real-time example. So global positioning system, as usual, for the first step, requirement. So the functionality of the designer for highway driving and similar uses for nautical or aviation uses that require more specialized databases. Okay, so user interfaces, the screen should have 400,600. That means 4,600,000 pixel resolutions. Okay, so the performance as usual, a display should take to more than 1 second to appear, and it will be verify the positions within 15 seconds. Okay, the cost, so the cost will be $100. The physical size and weight fit to be the form of the size. Power consumption will be a AA battery. So the specifications is more precise. It serves as a contrast between the customers and the architects. The second point, carefully written to so that they accurately reflect the customer's requirement and does so way that can clearly follow during the design. Okay, so what are the specifications we need for the GPS system design? Data received from the GPS satellite constellation, map data, user interface, operations that must be performed to satisfy the customer request, background actions required to keep the system running, such as operating system. So these are all the specifications for a GPS systems. Okay. So the next one is architectural design. So the architectural design is a plan of overall architect structure of the system that will be used to design the components that make architecture. The creation of architecture is the first phase of that what many designers think of the particular design. Okay. So in this architectural diagram, we have a GPS receiver, databases, and renderer. Renderer means we are giving so much of results in the sense it will give accurate results. That's called the renderer. After that, the display will show what are the source and what are the destination, what are the kilometers, and how much far from your source and destinations and locations, nearby landmarks. So these are on the designs when we go for this architectural design. Okay, the next one is hardware software architecture for moving map. So in this we are going to see about the hardware and software components. So the hardware means the display and the frame buffer and the memory and the CPU and the GPS receiver and the panel IO. The second one is position, the database search and the user database interface, renderer and the type. Okay. So these are all the hardware and software. Okay, so after this we are going to stop this process. So before that, the designing of hardware and software component. Last, for the GPS, we are going to integrate all the software and hardware components to perform a quick actions. Okay, so for that we are using the FPGA boards and the hardware boards. Okay, so such a platform we are using to design a GPS board, GPS machine. Okay, so after this we have completed the real-time applications of GPS embedded system design. Okay, thank you.